Now we move on to division of polynomials. And first what I'm going to do is review long division. And you may say, oh yeah, I've already done this. And if that's the case, then you can jump ahead to later in the video where you will see X's on the screen. And so if you don't see X's on the screen, then we're still doing long division. And the reason I want to do this is actually this is different in different countries. I have a friend who was not raised in the United States, and the way they set up their long division was entirely different. So if you are from another country, please, please, please watch this. If I wanted to take 135 divided by 11, I'd say 135 divided by 11, and it looks like this. You know, 12.2727272727. It goes on forever. So how would you do that in grade school? Okay, so you'd put the big number on the top of the fraction and little number on the bottom of the fraction, in this case, because you're getting it's an improper fraction. So you set up the division, you make this thing that looks like a square root symbol, but it doesn't have a little square root symbol on it. And you ask the question, how many times does 11 go into 13? You just don't look at that 5 there. You just look at however many digits you need to match up with however many digits there are over here on the left. And then you simply say, well, it can only go in one time. Too bad, so sad. Okay, so what we do is then we just say 1 times 11. So we take these two numbers, and then we multiply them and write them down here. Write the result there. And it's 11. And we're going to say 13 minus 11 is 2. And at this point, we drop the 5 down to here. We repeat the process again. We say, how many times does 11 go into 25? And the answer is 2 times. Right? And then we say 2 times 11. So it's just this one digit now. 2 times 11. It gives us 22. And that's, now we're done with the process because we notice that there's nothing left to drop. Now, you're allowed to say, let's put some decimal points and some zeros, and I can drop and make a 0. And that's not what we're going to do, but that's permitted. But that's not what we're doing. We're going to do the style that typically is taught first, which is remainder 3. Okay? So that's another way of writing that is 12 and 3/11ths, which is equal to 12 plus 3 over 11. It's the only time, please excuse my dear Aunt Sally, the order of operations, excuse my dear Aunt Sally. Order of operations is almost always honored, but the English convention of writing mixed fractions takes precedence over the math convention that two things written next to each other are multiplied. So you have to take this in context, and there you go. Okay, I'm going to do another example that's got a little more digits in it. And it's going to be 22, it's going to be 246,398 divided by 22. Okay, and again you just say, how many times does 22 go into 24? 1 time. Subtract. 22 goes into 26 1 time again, and 22 goes into 43 almost twice, but not quite. Sorry, no cigar. Okay, 21, drop the 9, and we hope this is 9. Then we get out the calculator, we say 9 times 2, and it tells us it's 9 times 22 is 198. Okay, then we do the subtraction and we get 21, and then we drop the 8, and I think we're going to have to do, what, 198 again. Okay, and so like 218 minus 198 gives us 20. So it's going to be remainder 20. Let's see if we did this correctly. You can say 246,398 divided by 22. And you may say, well, I don't know if I did it correctly. Well, here's how you know. The 11199 you did correctly. So you subtract 11199. What's the decimal? 0.9090909090. Well, you just multiply that by 22, which is this number right over here, to the in the left side here. That gives you 20, and then you're like, yep, that's the right remainder. So we're good to go. Okay, now we're done with the review of long division. If any of that did not make sense and you need more detail, there are videos online, but I would ask you to please let me know if you're in that situation. If you are a student from another country who has never seen long division done that way, just come talk to me, please. Okay, now we're going to talk about actual division of polynomials. There are two cases. Case one, I mean, there are more than two cases, but we're only going to cover two cases. Dividing by a single root. Okay, and in that case, here's an example of a polynomial, and this is equivalent to an improper fraction. You're going to divide by x plus 3. Okay, so there is a thing called synthetic division that can handle this case. If you know synthetic division, you are welcome to use it. I'm going to assume, first of all, that you don't know synthetic division, and I'm also going to assume that you're not going to be using it, but you're welcome to go ahead and do that. But for the purposes of this course, I'm going to presume people are not doing that. Okay. You take that big thing that's on top and you put it inside this division bar, just like we were doing with the numbers. And you see, you can think in your mind that x is kind of like 10. The same way we had numbers, like this would represent the number 1, 0. Well, here's a problem. This coefficient is 10. So the analogy kind of breaks down a little bit, but you can imagine that there's digits and that those x to some power is just a placeholder. Okay. So now we ask the question, how many times does x plus 3 go into, well, what we really want to know is how many times does x go into x to the 4th? And we actually don't care about the rest of this. So this is another way this analogy kind of breaks down. We're really only going to look, instead of looking at multiple digits, we're just going to look at the very first term of the two polynomials. So it goes in x cubed times, then you go through and multiply just like you did in grade school. Alright, and now what we're going to do is we're going to subtract. Now, when you're subtracting numbers, it's kind of easy to figure out that you're subtracting. I personally like to go in and change all the signs and then add. If you can keep the subtraction straight in your head, you don't need to do that step. I know some students really like to change the signs and some students really hate to change the signs. I'm the type of person who likes to change the signs and then add. You do it whichever way you like. Either way, at this step, it's going to say minus 3x cubed. You have to drop down the next term in your polynomial. And then you ask the question, how many times does x go into minus 3x squared? And the answer is minus 3x cubed. The answer is minus 3x squared. And again, we do this multiplication. The multiplication we're doing is we're multiplying minus 3x squared times x plus 3. And then we write it down here. So this is minus 9x squared. Again, I'm going to go ahead and change the sign so that I can add. I'm writing in blue that optional step. Okay, now I'm going to go ahead and add this. Minus x squared minus 2x. Now I'm going to say how many times does x go into minus x squared, and it's minus x. So then I'm going to go ahead and finish this up. Alright, so I have 3x minus 2x gives me x, and then plus 4. So near and yet so far. Too bad, it's not going to work. right? It's not going to come out totally even. It's going to have a 1. So the answer is remainder 1. Okay, and so this is the same as writing x cubed minus 3x squared minus x plus 1 plus 1 over x plus 3. So the way you handle the remainder is this remainder becomes the numerator of the fraction, and this guy becomes the denominator of that fraction. Okay, that's where they come from. Okay, hopefully that helps. I'm going to give you another example, and then this example is going to be pretty easy because I think I've done this in class. I did this thing in class. I did 3x over x minus 1 or something similar to this. I think my example in class was slightly easier. I can say, for example, minus 3 plus 3 in that numerator, right? I did nothing. So far I added 0. But now I can factor out a 3 from part of this, and I can split the fraction into two pieces. Okay, and then this results in saying 3 plus 3 over x minus 1. And this matters because why? Because now I can plot that, because that's based off of the parent function 1 over x. Parent function is 1 over x. We can plot now. Whereas before we were going to have a little bit of trouble plotting this guy because it doesn't look like we have a parent function for that. Now we have a new technique. Okay, now we can use polynomial division to do that for us, and if you don't understand this stuff that I did up here, don't worry, because now you have polynomial division, it'll do it. Okay, how many times does x go into 3x? Well, the answer is 3. Okay, then you go 3x minus 3, change the signs. Okay, then add, and then you get 3. So you get remainder 3. So it means 3x over x minus 1 is the same as 3 plus 3 over x minus 1. Okay? So hopefully you'll find that a refreshing trick that you can now use. Alright, I'm going to now go to the next example. I'm going to encourage you to pause the video and do it yourself, but I'm going to write it out first and then I'll tell you to pause the video. How's that? So x to the 5th minus 5x to the 4th plus 10x cubed minus 10x squared plus 5x minus 1. And if you recognize what I'm doing, it's out of Pascal's triangle. So yes, this is meant to come out even, and the math should be very easy. I want you to go ahead and pause the video and do that now. Okay. I'm not going to actually do out the steps, but this is the answer you should get. Of course, you could also go to Wolfram Alpha and verify. So you can make up your own problems, and then you can go to Wolfram Alpha and just see if you're right. Okay. Right. If we actually do a subtraction, yeah, I already changed the signs. Okay, you should notice that the signs are going to flip-flop as we go down the chain. Okay, I will let you guys mess with that yourself. Next concept. What if you happen to know, either you poked at it or I told you, that a function is 0 at a particular x value and f is a polynomial? Okay, what do you know? Well, it means you can factor it out. So let's say you stumbled upon this, or you poked at this numerically somehow. That's kind of a foreshadowing, by the way. And you figured out that there's a root there, and now you want to get it back out. So example. F equals x cubed minus 1. And it's really obvious that there's a 0 where? I mean, come on, you guys can figure this out. X cubed minus 1, this is what it looks like. Well, mostly. Yeah, there we go. Where does it cut through? Well, obviously x equals 1 is going to be where the root is. So now we want to factor that out. Okay, so let's go ahead and factor that out. X cubed plus 0x squared plus 0x minus 1. Now we're going to divide by x minus 1. And you may say, hey, wait a minute, why is it minus 1? Remember that the minus 1 is there because the root is 1. The factor